So I'm sure that at this point you've seen a slide that looks similar to this. So what I wanted to say about this is that, yes, there's these hierarchy of different cloud types, going from infrastructure as a service to platform as a service and software as a service. And I want to say what sort of workflow systems are that fit into this right now. And I think really sort of starting at software as a service, science gateways and portals are sort of a good example, of a software as a service workflow system. So you can run a portal, you log in through a web interface, and you submit some parameters that in the background then goes and runs a workflow on a local cluster, say. And an excellent example of this, I think, is Galaxy. Galaxy is a workflow system that's used in bioinformatics, and this is the model that they use. And you can actually take the Galaxy virtual machine, and you can deploy it in Amazon yourself and create your own sort of software as a service Galaxy workflow system. In terms of platform as a service, I don't think that there are, as far as I know, any workflow systems that sort of fit into this niche, which identify as having sort of a framework and automation. So you write your application, you submit it, and then all the resource management and everything is taken care of for you as long as you use their API. Maybe Amazon simple workflow service sort of falls into in between platform as a service and infrastructure as a service. But they don't, as far as I know, manage your resources for you. So they don't do the dynamic provisioning for you. That you're responsible for that and for data management. So it's still not quite platform as a service. And I'm going to focus mostly down here on the low end, on the infrastructure end, and how do you deploy workflows using existing workflow management system, which is Pegasus, that I'm going to talk about, on infrastructure cloud. So here's a typical grid HPC setup. And the reason why I show this is because this is the platform that we've been running in for 10 years now. And it has these components. So we've got a submit host that sort of runs on our local end on our institution that manages the workflow, has a workflow management system. And then across the network somewhere, there's a cluster with a head node that has a batch queue, something like PBS or SunGrid Engine. It's submitting jobs to a cluster of worker nodes that are all connected to a parallel file system. So the workflow management system is going to orchestrate the movement of data from your submit side to this parallel file system, submit some jobs, they're going to access that, produce output files, and then it's going to move the data back out at the end. And so one approach to deploying workflows in the cloud, and the one that I'm going to talk about, is to try to replicate this environment in a cloud, in an infrastructure cloud. And so the thing about it is that grids and clusters are already configured, right? So there's an administrator that works at NERSC or wherever, and they administer this cluster for you. They set up all the software. But in the cloud, basically what you get is these raw virtual machines. You have some infrastructure services, but they're not set up for this type of workload. They're not set up with batch queues and things like that. So you have to deploy that yourself. And so these are called virtual clusters. So the challenge is how do you deploy these virtual clusters? And I think you may have already heard a little bit about Nimbus Context Broker in earlier talks. But there's some tools to support this. Chef and Puppet are these configuration management tools that allow you to specify policies for how your machines are configured. Nimbus Context Broker, which I think you've seen, allows you to sort of create a description of a virtual cluster that you want to deploy, and it will manage the provisioning for you. Cloud Init, Star Cluster, they're all similar. And I'm going to talk about Wrangler, which is a tool that we worked on to do this. So the challenges of this are that virtual clusters are composed of a lot of different nodes that play different roles. So in the environment that I was talking about earlier, you have a submit node role, you have some number of worker nodes, maybe have some file systems, maybe a batch queue. So you have to coordinate and configure all these different virtual machines to deploy your application. And infrastructure clouds are dynamic, so you have to do this in a way that at runtime. So you can set it up manually, but you need to tear it down every time. Every time you run an application. You could keep it running sort of forever, but you keep being charged for that if you're running in, say, a commercial cloud. So you need to have some automated way to set this up. And scripts work to a point, but for complex environments, complex configurations, they really break down and become unmaintainable. Okay. So like I said, you need this automatic deployment that's scriptable and repeatable. You need to support the complex dependencies between VMs so that, for example, your worker nodes can depend on the file system so that they'll only be configured in the case of that the file system exists. You need to support dynamic provisioning so that the system can add nodes at runtime. You'd like to support multiple cloud providers so you avoid this vendor lock-in. And this, there's some standards emerging, I guess, in terms of interfaces for clouds. So this is something that's not too hard to deal with. And then you also need monitoring so that you can check to make sure that the cluster is still running if you have an application that runs over a long period of time, and report errors if an error occurs. So the Wrangler service is a web service that has these components. So there's a central coordinator that takes requests from clients, and then for each cloud provider in a virtual machine image, there's these agents, the agent component that talks to the coordinator and deploys your configuration on the nodes. So what the clients give to the coordinator is this declarative XML description of the cluster that has DAG-based dependencies. I'll talk about that more in a second. And then as part of that, there's these user-defined plugins that say what software service you need to deploy and how you should configure it. And these are can be regular shell scripts that the user has on their machine that then get transmitted by the coordinator to the virtual machine at runtime. And then it supports multiple interfaces from Python API, if you want to call it that way, or command line tools or whatnot, and also support excuse me, multiple resource providers. So currently it's working on EC2 and Eucalyptus, and we're going to add support for Nimbus and OpenStack soon.